Alright, so we'll start the unit 5, that is your guidance systems. Guidance systems topic comes into picture with respect to the missile. So we'll discuss about the missile guidance phases and the classification of the guidance systems. Nowadays, the guidance system is also used in the aircraft, in the UAVs and other vehicles, like in the as the automation comes into picture. So it will be also helpful for that perspective as well. So guidance phase during the missile flight are like how you differentiate between unguided projectile and a guided missile is the generation of the guidance command, right? If we cannot control the projectile which was thrown, or we cannot control the vehicle, then it is unguided, right? Which will just like you fire and forget kind of things. The guided missiles or guided projectile is that when it can be controlled using some of the commands which are known as a guidance commands, which will be try to change the missile's flight direction and flight trajectory so that it will be keep on track. The guidance command is nothing but the lateral acceleration command, which the autopilot translate into the amount of lift required to produce so that desired turn rate can be achieved, which will be like rate of change of velocity so that it can be changed in x, y and z direction. The part of missile trajectory for the surface to air missile and air to air missile can be classified into several guidance phases. Like all the guidance phases, we will not require to employ the same guidance strategy. Like initial phase, we are our objective is different, so we employ the different strategy. In the terminal phase, our objective is different, so we employ the different strategy of the guidance. So if you take example of the air-to-air missile, the guidance phases are the program maneuver, the mid-course and the terminal phase. The program maneuver is the phase during which you objective is to clear the launch vehicle. Like you need to clear your missile from the vicinity of the vehicle or aircraft from which you are launching, so that it will not hit its own aircraft. So here our objective is clear. We need to throw the missile away from the launch vehicle, launch aircraft, and in that we don't require to achieve the direction or velocity. Just we need to clear the distance so that missile can go away from the launch aircraft, and then in the mid course we need to take the missiles toward the target. So here we need to achieve the certain direction and the velocity, so we require to employ some guidance strategy in the mid course guidance. In the terminal phase we need to lock the missile to the target, and we need to maintain the maneuverability of the target, and we need to hit. So here we need to apply the sophisticated guidance strategy. So we have three phases. Program maneuver, we don't require to employ the guidance strategy over here. It will be short period of time. In mid course we need to apply certain guidance strategy which will keep your missile toward the target, and in the terminal phase where is the last few seconds we need to apply the guidance strategy so that it can lock the target with using the different sensors, and our objective can be achieved. Same things happens with the surface to air or surface to air missiles, where our first maneuver is the boost phase or launch phase, the second maneuver is the mid course phase, and the third maneuver is the terminal phase. In the boost phase or launch phase, our objective is to clear the launcher, achieve the velocity and altitude, irrespective of the location of the target. So here we don't require to have some guidance systems to be employed. In the mid course, our objective is to take the missiles toward the target. You need to clear or cover all the horizontal distance and the range. So we require to keep the missile in the track. So some of the missile guidance strategy we need to employ. In the terminal phase, whether your target is moving or stationary, we need to hit the target. So we need to apply the best possible guidance strategy over here. Same goes to the surface, where our target mostly will be less maneuver or stationary. So we know the destination, and we can same way you can classify the guidance phases like the launch phase, mid course and terminal phase. Similar same things, just like depending on the objectives, some here and there particular objectives can differ. Now how you classify the guidance systems? We know the three phases, and we need to employ different guidance strategy over these various phases. So depending on that we need to employ, like sometimes your target is highly maneuver, so which strategy you need to employ. Sometimes your target is stationary, which strategy you will be employing. So depending on that, you can classify the guidance system into the 5 different categories. One is the command guidance, one is the homing guidance, the beam rider guidance, inertial guidance, and stellar guidance. This which is the classification is based on the which type of the command signals or command strategy you are employing. Like command guidance, how you provide the command to the missiles. Homing guidance, which will be like how the signatures or the sensing of the target you achieve. Beam rider, like how you keep your missile into the trajectory using some of the artificial beams. Inertial guidance systems will be employed, and the stellar guidance. So we'll be discussing in detail all these 5 strategies. First is the command guidance. In this method, the guidance signal is transmitted from the launch site to the missile, giving the missile its deviation from the path line and the line of sight. So we have the ground station which will be uh, hitting or transmitting the electromagnetic wave toward the target, which will locate the target, and the target location and the direction can be transmitted to the missile using the command guidance system. So you different type of command transmission strategy you are applying, so that the missile will always keep pointed toward the line of sight of the target, and this logic can be transmitted to the control mechanism, and accordingly the missile can be maneuvered. So one method is the wire link. You attach some optical wires with the ground station and the missile, so that through this optical wire you can transmit the data or command signals to the missiles, which will be carrying the what you call information about the target. Maybe it is your surface to surface missile, anti-tank missiles, and all. As your wire is attached, it will not be long range, it will be short range. Up to 4 kilometer you can be achieved using the wire. So thin wire is wound on the spool of the missile, and it is unreal as your missile will be traveling. Another method is the radio link, like where you have transmitter and receiver fitted in the missiles, as well as ground station. Ground station will be transmitting the control signals and the command signals to the guidance missiles, and that signal will be transmitted to the autopilot system, and then accordingly the action will be taken. Example you take is anti-aircraft missiles, which will be a type of radio command guidance system. Third method is the fiber optic link, where you establish the fiber optic link so that high speed transmission can be happen. So which are typically 3 type of transmission mechanism you provide in the command guidance. So basically command guidance, your missile will not carry the sensing element, it will rely on the ground station all the time. Ground station will be transmitting the command signals, missile will having the receiver which will receive the command signals, and that command signal will be processed in the autopilot system, and accordingly the maneuver will happen. So command guidance advantage is that the command guidance system is very little guidance equipment needed to carry in the missiles. So you don't require to carry the transmitters, only receiver will required, so that you are not required to sense the location of the target. Only you are depending on the ground station. Ground station will be locating the target and sending the location, and according to that your command signal or steering signals, so that can be produce lightweight missiles, or more payload can be attached, but that will also having like smaller body can be fine. Another is that it cannot be used against the multiple targets, because every time one single target need to have single line of sight, and every time you need to produce a steering command for that. Again, your command signals are from the ground station, so there will be a lag in the communication, so there will be delay in the communication, so that will be the disadvantage in this case. Another is the homing guidance systems, where your transmitter and receiver are both fitted in the missile as well. So homing guidance is generally used for the short range missiles. This system will receive the signal reflected or emitted from the target, like you hit sinking missiles, or the missile will be seeking the reflected electromagnetic wave, so which will be the seeker kind of missiles will be using, where these receivers are fitted in the missiles. It will be transmitting the signals the signal will be reflected from the target and it will be received back to the your missile systems, which post process and keep your missile in the line of sight. So it will be, you don't need to rely on the ground station. So in the homing guided system, there are typically three types: active homing, semi-active homing, and passive homing. In the active homing means your transmitter and receiver both are fitted in the missile as only. You transmit the signals and wait for the echo signal be reflected from the target, and that will be giving you the what you call strategic command steering signals, which will be post processed by the autopilot system, and accordingly the missile will be moving in particular direction. In semi-active guidance, the missile will be carry only the receiver. The transmitter will be part carried by the ground station. Ground station will be transmitting the signal. The reflected signal will be received by the missile. So it will not require to carry both transmitter and receiver. So this will make your missile lightweight, and it will also less power consumption. In the passive guidance, you are not transmitting the signals, only you are receiving the signals, or which are emitted by the target, like heat sinking missiles, where you are receiving the heat signature, where you don't require to transmit anything, only you are following the heat signatures or emitted signals which are from the target, and you keep following that emitted signals, and that energy will be deviation in the energy will produce the steering command. So these are typical three type of the homing guidance systems. One is your active homing guidance system, one is a passive homing guidance system, another is the semi-active. So over their own have their own advantages and disadvantages. Another classification is a beam rider, where your ground station will be creating artificial beam over the target, and your aim is to keep the target always in the middle of the beam, and the missile will always fly into the beam, so that the target will be always in the line of sight and in the middle of the beam. If your target is deviating from the center line of the beam, there will be a signal will be generated, and that signal will be translated into the steering signals, and accordingly the beam will be moving and your missile will be moving, so that your target will be always in the center line. So that is how your beam rider missile will be working. So in this method, the missile is fired into the beam and thereafter get guided over the beam until it hits the target. The sensitivity of the laser is commenced of the flight and toward the end of the missile will be like here. If your target is more maneuverable during the terminal phase, and if your target is more maneuvering, you need to always keep moving your laser or your beam, so which will be a difficult task. So that is a, like, you cannot always which will not be working more efficiently during the terminal phase. It can be work efficiently during the mid phase or for the target which are stationary or less moving. Another is the inertial guidance systems. The inertial guidance system is that self-sufficient guidance system, where you are not relying on the outer world. All the equipment you require to like for the guidance systems which are carried by the missile itself. It is similar to the inertial navigation system, but it is not using the navigation component. Here we are using the accelerometer and the gyroscope to find out the range and bearing of the missile, and from that we can able to locate the keep tracking the target. So in and we can able to find out or keep our missile in the line of sight of the target. Here advantage is that it is always not transmitting any electromagnetic signal, so it cannot be jammed, and it can be fly in any weather. Another is the stellar guidance system, which is used for some strategic missiles which are using the some star constellation, as the star tracker will be keep tracking the stars, so that during the mid course missile will keep tracking the stars, and it will be combining the different location of the stars, and it keep flying toward the direction. So which these are stellar guidance will be used during the mid course of the flight. Some of the useful concepts which are used in the guidance systems or while developing the guidance laws, there are some of the command like that, some words which are used. One is your lateral acceleration, which also known as the latex, which is the acceleration that required to be applied by the missile to achieve the desired turn rate. Like if you require to apply the acceleration toward x, y, and z direction to keep your missile flying in the line of sight, so that acceleration, how you apply, that is your lateral acceleration or latex signal. It is usually applied in the direction close to the normal to the missile. That is why it is known as the lateral acceleration, and it will be perpendicular to the longitudinal axis and the velocity vector. In fact, the guidance command generated by the guidance law is usually expressed in the lateral acceleration or latex signal, like how much latex signal you are generating. That's how you are calculating the while designing your guidance law or guidance system. Another is the line of sight rate, that is rate of change of line of sight. During the missile target engagement, the imaginary line between the missile and the target is known as line of sight. Now as your target is moving, so line of sight is also moving. So the rate at which the length and orientation of the line of sight is changing, which is known as the line of sight range. So two parameter or two terminology we are using to define the guidance law and guidance strategy are the latex signal and the line of sight rate. Another is the closing velocity. This is the velocity with which the missile closes on the target. Obviously, it is given by the rate at which the length of line of sight is shrinking, like the how your line of sight is decreasing, which will be translated into the closing velocity, which will be in the negative. Like as you are going toward a target, so length will be decreasing. It is also the Doppler relative velocity of the target with respect to the missile along the line of sight. Another is the miss distance. This is not the distance by which you are missing the target, but this is a distance of the closest approach of the missile to the target. Like we need to provide that when your warhead will be exploded. It is not always that your missile will be hitting the target, then your warhead will be exploded, but we need to finalize some of the distance that after that proximity your warhead will be exploded. So that is defined by the miss distance. So this is the minimum distance of the approach. Okay. So when your proximity fuse will be detonated and which will be exploding the warhead and the target can be destroyed. Like here, the missile and target. So when both are at the minimum proximity, that will be your miss distance. After that, again your missile and your target distance will keep on increasing. Then comes the time to go. Suppose we record a trajectory data of the missile target engagement and find that engagement ends with the interception time, and the time to go is the time from the initial time to the till the time you are hitting the target. So it is given by final time minus t, that is given time. So time to go is equal to final time when you are hitting the target minus the time right now. So if you start from 0, so 0 to tf will be your time to go. That is how much time you require to hit the target, which can be calculated by the r divided by rate of change of r. R is the range of the line of sight and r dot is the rate of change of line of sight. So we know the distance between your target and the missile, which is a range or line of sight distance, and how far it is, how close reducing it is your r dot. Negative sign indicate that it is reducing. So from that we can find out the time to go. Then comes the blind zone, where in the blind zone, the homing guidance system, the seeker has to keep the pointing towards the target to track. However, during the last period of time, during the terminal phase, missile could be pointing in such a direction that seeker has to turn at very higher angle of attack rate, and during this time the mechanism will not be supporting due to the mechanical limit and we cannot see the missile. So that is known as the blind zone of the missile.